Hello viewers, I am Kausalya. Today we are going to discuss problems on RC series circuit. So here the problem is a capacitor having a capacitance of 10 microfarad is connected in series with a non-inductive resistance. Right, non-inductive, it doesn't have any inductance. So it has a resistance of 120 ohm across 100 volt 50 hertz. Right. So here we are having a capacitor in series with a resistor. The value of this capacitance is, it is given as 10 microfarad, and here the value of resistance is given as 120 ohm, and this is connected across 100 volt 50 hertz supply. Right. Calculate the current, power, phase difference between current and voltage. Right. So first write down the given datas, right? So here the first thing is we need to calculate current, right? So current is given by the formula V by Z. So V is directly given in the problem. We need to calculate Z, right? So here we know the value of resistance, but the value of XC we don't know. The value of C is given, right? So from the value of C, we have to calculate XC. So XC is given by 1 by 2 pi FC here. So just substitute the values. The value of capacitor is 10 microfarad, right? So 10 into 10 to the power minus 6. So here the value is 318 ohms. So just substitute it in the expression for Z. You see square root of R square plus XC square. R is 120 and XC is 318. Right. Just square and finally the answer is, you see, 339.8, which is more or less equal to 340 here. Right. So the value of Z is 340 ohms. So it is easy to calculate our I, right? So I is given by V by Z. So V is 100 divided by the value of Z is 340. So 100 by 340, that gives the answer as 0.294 amps. And the next thing is we need to calculate the phase difference. So phase difference is given by tan inverse of XC by R. So we know the value of XC, we know the value of R. So just substitute and here the answer is 69.3 degrees. Right. So here again to calculate the power factor, you have to include cos pi. Right. So cos pi gives cos of 69.3, that gives 0.353. Since here it is a capacitive circuit, the power factor is said to be leading. Right. And the next thing is to calculate the power. So power is given by VI cos pi. We know V, we know I, we know the power factor. So just simply substitute and here the final answer is 10.4 watts. Right. And here just I forgot to tell you one thing. Here you will be getting answer in terms of point something. Right. So the thing is you have to multiply by 180 and you have to divide it by pi in order to have the angle in degrees. Right. So after getting this answer, just multiply this with 180 and divide it by pi. Right. Now solving the same problem in phasor form. So here the reference voltage is 100 with an angle of 0. Right. Since it is an RC circuit, the expression for Z is R minus JXC. So just substitute the values and we are converting this rectangular form to polar form. And I is given by V by Z. We know V, we know Z. So just substitute here. And the current is 0.294 with an angle of 69.3 degrees. Right. Therefore, the phase angle pi is 69.3. Since it is a positive angle, it is said to be leading. And the next thing is power. Power is given by VI cos pi. We know V, we know I, we know the value of pi also. So just substitute it and here we are getting the answer as 10.4 watts. Right. You can use any one method to solve this problem. Either way of solving is correct. Okay, anyway, the final answer remains the same. So just choose which method is comfortable for you. Right. Now we will proceed with the second problem. The problem is a voltage of 125 volt at 60 hertz is applied across a non-inductive resistor connected in series with a capacitor. The current is 2.2 amps. The power loss in the resistor is 96.8 watts. Calculate the resistance and the capacitance. Neglect the power loss in the capacitor. So here you see again we are having a non-inductive resistor, that is it is a plain resistor, and a capacitor. They are connected in series and the current is given and the power loss in the resistor is given and the supply voltage and the frequency are given, right? So here the thing is we need to calculate the value of R and C, right? That is we need to calculate the values of system elements. So first write down the given datas, right? If you like to draw a diagram, you can draw, right? So here we are starting up with the power loss. So power loss in the resistor is given by the formula I square R, right? Here the value of power loss is given, the value of I is given. So just substitute it and calculate the value of R here, right? The next thing is we need to find the value of C. So we are calculating this formula. We are calculating the impedance. So Z is given by V by I. V is given, I is given. So the value of Z is 56.82. So in a RC series circuit, what is the formula for impedance? So it is given by Z square is equal to R square plus XC square, right? We need XC square, then only we can easily calculate the C. Therefore, XC square is given by Z square minus R square. And XC is nothing but square root of Z square minus R square. So here the value of Z we had calculated, just substitute it here. And the value of R is also we have done already, 20. So when you solve, the answer is 53.2 ohms. So what is the formula for XC? It is given by 1 by 2 pi FC. Right. So we need to calculate C here. So I am moving C to this side. I am shifting this 53.2 down. So here once you solve, the value of C is calculated as 49.9 into 10 to the power minus 6 farad, or simply 49.9 microfarad. Even you can write it as 50 microfarad because more or less the values are same, right? So second problem gets over here. We will move to the third problem. So the problem is the resistor R in series with capacitance C is connected to 50 Hz 240 volt supply. Find the value of C so that R absorbs 300 watts at 100 volt. Find also the maximum charge and the maximum energy stored in the capacitor. So here again you see this is an RC series circuit and we are having a supply voltage, right? Here the different things that are given are, you see R absorbs, that is the power in the resistor is 300 watts and the voltage across the resistor is 100 volt, right? So we need to calculate the maximum charge and the maximum energy stored in the capacitor. So first write down the given datas, right? And draw the diagram here. Right. So in this case, as we already know, you see, we can use this formula, that is V square is equal to VR square plus VC square, right? So we know V square and we know VR square. So from this we can easily calculate the VC. So just substitute the values here, right? So we need VC, right? So VC square is given by V square minus VR square, and VC is nothing but square root of V square minus VR square. So V is 240 and VR is 100, right? So just substitute the values here and the value of VC is 218.2 volts, right? So here the power absorbed is 300 watts, okay, by the resistor. So it is given by I square R, right? So here this I square R it can be rewritten as, no need to rewritten, power absorbed has two formulas. One is I square R, other one is V into I. Okay. So here we are using voltage across the resistor into I, which is equal to 300. So I is nothing but 300 by VR. We know VR as 100. So the answer is 3 amps here. And VC is given by I into XC. So XC is given as VC by I here. Right. So the VC is 218.2 divided by the value of I is 3. So the value of XC is 72.73 ohms. So XC is nothing but 1 by 2 pi FC, right? We know the value, we have to find C. So move C to this side and shift this 72.73 downwards. And we know the value of frequency. It is given in the problem. So just substitute it, and here the answer is 43.77 microfarad, right? And here the next thing is, we need to calculate the maximum charge, right? So here the maximum charge, the formula, it is given as C into maximum VC, right? So this maximum VC is given by root 2 into RMS value of VC. So square root of 2 into the voltage across the capacitor we had already calculated, right? So just substitute it, and here the maximum VC is 308.6 volt, right? So maximum charge is given by C into maximum VC. So the value of C is 43.77 into 10 to the power minus 6 into VC is given as 308.6. So that gives the answer as 13.5, right, MC. So that is millicoulomb, right? Maximum energy stored is given by the formula half CV square. So half into the value of capacitance we had calculated, and V is nothing but, that is the maximum VC, right? So just substitute it here, and the final answer is 2.08 joules, right? Here comes the end of this problem. If you have any doubt, let me know in the comment section. Thank you.